several business intelligence centric knowledge workers, teams at Esprints, IBM, HP, and other Fortune 500 companies in the fintech, telecom, and biotechnology domains. Now, I would like to invite our today eminent speaker, Raghu sir, for his valuable talk on impact of data analytics in decision making for learning corporation. Please, sir.
Well, thank you very much for the pretty impressive the way you say it. It makes me look as a wow, did I achieve all that? So thank you for a great introduction. Honestly, I thank you for. I hope I'm pronouncing the university name correctly. I apologize if I haven't. ICFAI Datadriven for the honor of addressing the students and academia and industry as well, and on a very critical, pivotal topic, especially at the juncture of COVID hitting the world and working from home and SaaSification of our work becoming so critical. I sincerely appreciate Professor Vinay, Dr. Das, and Dr. Kumar, Sanjeev, Mr. Sanjeev. I hope I got your title right
Yes,
for the
indeed.
honor. I'll be keen to uh, contribute to the success of ICFAI Data Do in any capacity. So with that, let's actually fast forward to the topic that we're going to talk today. The way I go about presenting is a conversational tone. Very few of my slides would have real content of English. Most of them would have pictures and mostly pictures, and I'll explain what it is. Then we'll quickly pivot to the Q&A session, which I believe is about half an hour from now. I'm fine if it runs over. I have no place to go other than, I guess, my bedroom after this is over. So we are all good. So let's look at this topic, right? In impact of data analytics and decision making for learning corporations. There are three big entities here: data analytics, decision making, and learning corporations. These are three critical areas for us to really understand what. First off, we need to obviously understand the definitions at a very high level. And oh, by the way, if my audio or the slides don't move, I haven't yet moved to the next slide yet, um, cause any disruption, do let me know through the chat. So let's first go on to quickly look at it from a definition standpoint and then pivot to what we want to do from an agenda standpoint for the next half hour or 1 hour. So if you look at these, what we are trying to do here is, hey, let's get some definitions in order. This is slide number 2. I would call out the slide, and I have circulated the deck to Mr. Das. So Mr. Das. So he would send it out or distribute to the entire larger audience. So let's get some clear practical definitions out for data analytics and decision making and learning corporations. So the previous slide, we talked about learning corporations, but in this slide, we kind of call it democratizing AI. The point here is when a company is going to be pretty strong and believe and invest in itself into using analytics, the use should be widespread across all areas of the company, not just IT or not just the BI team. It should be the senior, middle, lower, and CXO management staff. So that's the democratizing the part comes in. The AI is, we're kind of fast forwarding thousand steps, I guess, leapfrogging to the not the very distant future, immediate future in the next decade or so, especially for students who are going to graduate from the university, mostly in the finance and fintech and technology areas. AI would be next to living and breathing. We'll see that as we progress through the slides. So the data analytics from the first definition matures, morphs, and graduates, if I may, as AI. Now, the big more data analytics and big data are conjoined twins. You got to understand big data if you really want to be pretty strong in okay. Um, in order to understand data analytics, you need to have a working knowledge of what big data is. And when this term big data is thrown around, it's not that we woke up one fine day and said, "Oh, now it's a day of big data." Small data or pure play Excel data is no more going to cut uh, be our day-to-day way of looking at data. We always had the big data volumes in the past as well, but due to very leapfrogging of really advances in technologies of storage, processing, chip design, and the way data is handled, we are able to ingest and land a lot, huge volumes of data. Now, the crux of understanding big data are two main concepts: the five V's, as we call it, which is the volume, the velocity, the veracity, the variety, and the value. And how do you ingest, which is the I, and how do you harness? Harness is like cleaning the data, curating the data, cleansing the data. And the other H is how do you harvest? Harvest is how do you build intuitive analytics and insights out of the data. We're going to look at it from slides 4 through 10. And then we go do a deep dive in data analytics, which is like, let's take a look at what BI is, what's a data engineering, what a data engineer does, what is machine learning, and what does a machine learning engineer does from a day-to-day. How do these roles differ? Each role is different. And then we look at what's called as what are the standard right way to go about building a data analytics model, which in our today's current present world is any machine learning model. So that's pretty much a agenda overview. And let's go to the next slide where we're going to talk about the definitions. This is slide number 3. Are we good, Amit? We're on slide number 3. If you guys are not
Okay, sir. It's
able
very nice,
to,
sir.
okay, good. So let's actually look at it from a operational and action oriented and where the rubber meets the road, which means where really activities are carried out definition standpoint, rather than the bookish definition of what data analytics is. So we basically are saying analytics is you got to examine the data and you got to draw conclusions. The process of our ability to intelligently draw conclusions by examining the data is data analytics. That's on the English side. We're going to only have English sentences in this slide, period. The rest would be content of what data analytics is all about. Now, the next part with the data-driven decision making is critical to understand. We are basically saying, hey, we're not going to rely on gut feeling saying, oh, the sales last year were 20% more than 2018. So whatever we did last year, let's continue. That's just anecdotal. That's a gut feeling. That's not a decision driven and embedded in analyzing what the data was for 2019. So we need to make decisions based on insights derived from the data that we have at hand or information that we can glean or conclude from. And then finally coming to what a learning organizations are, it's critical to understand that a learning organization, the way you get to democratizing AI is to make sure you take your employees, your worker bees. The worker bees are not just programmers, it's the subject matter experts. So in health, in a hospital, it could be the physicians, it could be the nurses, it could be the healthcare workers, apart from the IT staff. If it's banking, then it's your the loan officers, and if it's a risk modeling, it's the underwriters as well. How do we make all these different, hitherto non-IT or non-data savvy folks more glued in and married and tied in to the data side of the equation? So we need to upskill them. Upskill them is not making them learn Java or Python. That's more for the busy bees, the programmers. Upskill is how do I critique the data intelligently based on my domain expertise in that specific area. So that's kind of a broad 30,000-foot overview of what democratizing AI and learning organization is. And the more you imbibe and inject this culture and incubate this culture of learning, then the knowledge transfer across all the different swim lanes of a company would really become pretty transparent and widespread. So that's about this slide. And let's actually now get to the meat of this data and analytics content. Let's look at the 5 V's of big data. How we're getting huge volumes of data now. Why is important to understand. Not that we only started getting believing that we had big data, huge volumes of recent past, that is 10 or 15 years ago. What's happened is in the advances of our ability to ingest data at a high speed, that's bucket one. And also, simultaneously, if in the audience there are folks more from the data and IT and technology background, it's important for them to pay attention to this point. Up until 2006, 7, 8, or early 2000s as well, most of our ingesting and querying data is through the COB normal forms and RDBMS structures. So you kind of store data into tables, OLTP data into row and columns, and data warehouses into fact and dimensions. This is a little more technical, but then the point is important to understand. There is an inherent limitation. If most of your query searches would have to go through rows, columns, and multiple tables before they get to an answer. So when you issue a command to search for where is Amit Das now, then it has to go, the search part and the data part are not co-located. They're on different infrastructures. So there's an inherent latency involved from the search, which is called compute, and the data cycle, iteratively finding where the data is to complete. Now that's a limitation of the architecture of the infrastructure. Fast forward to the big data architecture, these two co-locate on the same computer. But you don't really use the word computer, you use the word called node cluster. In any case, the point is we're able to ingest huge volumes at a high speed and of different variety, which is like structured data, which is like rows and columns of bank, name, age, census, and also sensor data, like for instance, weather report, and then satellite information. That's variety. And for a little dwelling a little, peeling the onion and going a little lower in detail for IT guys, it's like JSON, and then it's like a row column formats and even non-JSON formats as well, JPEGs and images and so on. Now, when you have all these huge volumes, high speed of at which the data is flowing in, and you have different type of data kinds coming in, the fourth point is veracity. It's a challenge. That is, how do you verify, cleanse, curate, and convince ourselves that this is the right data we're looking at. And from this data, how do we get the value out? That is, how do we get the insights out for the company? That would have invested millions of dollars to um, ensure that we basically get insights and become a data-driven decision-making company. That is the essence of data analytics. So here we are saying, hey, let's first know how to ingest data, how to harness data, which is like curating, cleaning, and all that, and then harvest, which is like cleanse, which is fundamentally building in insights. There's not much to spend here. Now let's go to the next one. Let's look at the volume part. On an average, every day, this is every day, 40 zettabytes, which is 10 to the power of 21 bytes of data, which is 40 times more than the number of stars in our universe, if you count, is the amount of data that we all are data centers for Google's, for Amazon's, Facebook's, Twitter's, banking are handling. So look at the volume and look at the variety. And the last slide has got all the references. So you can, at your leisure, you can spend a lot more time on those websites and understand more. The point is, data analytics is critical to understand that, hey, there's a lot more data than just using an Excel. Excel is COBOL. Yes, it's great to power pivot and put data into quickly do a sum and an average and histograms and pie charts. You cannot build trends. You can, I guess, to a point, do a Monte Carlo simulations and so on. But it's limited. It's not industrial strength. You need to really look at petabyte scale data or zettabytes. And there's another unit of measure beyond zettabytes, which is zettabytes. So with our um, 10 to the power of 18 quintillion, as it's called, records or bytes of data flowing in every day. So the volume, variety, the 5 V's, the way we ingest, harness, and harvest are the essential knowledge areas that a data analytics resource, be it the IT guys or be it the uh, swim lanes in the company, need to understand. Now let's take a look at how it's kind of implemented, right? My presentation would be less focusing on the high level and more on the detail, which is very critical. So on the leftmost, we have the sources of data flowing in. We need to build what are called pipelines of extraction for regular data, which is your Oracle table type data, and the other two, which are like non-Oracle type, which are called NoSQL databases, not only SQL. SQL are row and columns, RDBMS, which means every row defines an entity. And if you have 15 columns in a row and you want to aggregate the fifth column and then 1 million rows, you need to pull out 1 million rows and then go after the fifth column. But you have to look at all the 15 columns. So it's an inherent loss of latency and inefficient querying. How if we organize the same, instead of one row having 15 columns, each column being a table and each column having a key. So you on the fifth column, you don't go across the 1 million, you only go deep to the fifth column table using the key and aggregate sum, min, max, average, or variance, or whatever it is. So that's called a key value pair columnar structure, which is your NoSQL databases. Most of your data, which is your Twitter, your Facebooks, your IoT, is kind of lodged or saved in those formats. Now, where do you save them? Is in storage, cloud storage. Not really, yeah, you could still store them on your on-prem, that is on-premise databases, data centers. but then that's too expensive. Somebody's got to maintain the heating and cooling costs, which is um, extra expense for a company which is only going to sell, say, books or sell textiles or sell, you name it. Why should they be investing 5% of their revenues and profits to heat and cool and data centers? So you kind of offload that work to companies which do it well, which is Google. Um, then you have a bunch of others, Amazon and Microsoft and so on. So these, what you see there, AWS S3, Google Cloud Storage, Hadoop, Microsoft Azure, are there the storage. And then above that is called an Airflow. Airflow refers to what's called as a workflow management. How do you orchestrate controlling the source pipe data extraction and extract pipelines and landing the storage, then cleaning and scrubbing and building business rules, um, which is your transform pipelines. And then the last part is where the data analytics comes in, which is your data warehousing and BI. In order to get to the last step, you need to first carry out the remaining 9 steps before, which is critical for a data analytics vested student in academia and industry, if you guys are from the industry in this audience, to understand. And especially if you're in the decision making roles in your respective organizations, you cannot look at data analytics as in isolation, saying, "Hey, let's build a dashboard. Let's have the IT BI team build a nice self-service model." No, you need to know what sources are, how they're ingested, where they're coming from. You may or may not really be embedded in delivering the solution. Since you're going to invest in the solution, you need to ask these questions as a investor in an internal project. So that's very critical. I'm going to move to the next slide. So the point I'm making is data analytics is the last column here, which is BI in this context. But as we see, it's more than just BI. But you can't just get a BI without really understanding the first 9 steps. Now let's take a quick, we kind of talked about what data analytics is. We talked about the 5 E's. We talked about the harness, harvest, ingest. We talked about a quick snapshot of how things move. But if you look at the history, academia, education, and industry have always been conjoined twins or uh, married at the hip, as the phrase goes in US. Like you, it's impossible to separate one from the other. It's a very tightly integrated collaborations, if I may, between academia and industry. Industry invest and funds departments, but the research is carried out exclusively, not just for an industry, but partly though, and certainly more from a academic standpoint. We had always statistical computing, and we are pretty strong in those areas in India, ISI to name a few, and Professor Vinay and I have gone through our share of masters in statistics. We know how dense it is. Our professors would fill the whiteboard with chalk and cough their way through lectures, I guess. But it's dense. The statistical computing, understanding stochastic process or operations research or linear programming or poor CPM and design of experiments is great, is needed. But it was so isolated to the academia that it was never surfaced up to the masses. And that evolved. We had machine learning back in the 17s as well. Export systems, AI were there, but they never democratized. They were kind of niche skill, very hard to, almost like learning assembly line coding 8088 or i4, I guess Pentium chips now, Intel chips now. Then we moved to the 80s where we had um, a focus on let's actually build large databases, VLDBs, very large databases. And this is more the 80s were more in the chip design, the infrastructure side. And then you go to 90s, we were able to then ingest a lot of data. We're still not in the big data um, phase or era yet. And we're able to mine the data. We're able to kind of have on the data warehousing side, Ralph Kimball and Bill Inman as the fathers of those areas, as they call. And this is Amit and I were chatting before this call. This is a great field where most of the contributors, significant contributors, if I may, are alive, contributing, and um, speaking up and defending, or if not editing their, amending their work that have already contributed. So if you look at data mining and data warehousing, Bill Inman and Ralph Kimball are very active still. And then now let's look to the second wave, which is where education and industry really got together. Excuse me. This is where the storing part of data and mining the data in large databases as VLDBs took to schools, academia, and colleges, where they started building information system programs in the 2000s very aggressively. Up until then, were engineering colleges, and they were more driven by uh, technology, computer engineering, and whether you call it ECE, whether you call it CE, that's more engineering focus, more on the chip design and more on low-level coding, assembly level coding. And then the 2000s really, late 80s, early 90s, mid 90s, the C really got in, and then the 2000s took off from being able to uh, transition to having the students get into management information systems, looking at data as business analytics rather than just a what do you call a data mining exercise exclusively tied to academia. Let's bring it out into the industry, and that's where engineering programs really spiraled off and tangentially grew into bioinformatics, health informatics, and systems analysis and design. And then, as I was talking earlier, our ability to co-locate the data and compute cycles, and then look at ingesting data not as a VSAM, ISAM, that is COBOL, sequential access methods, index sequential access methods of how files are stored or data is stored, to a Hadoop way of file-based structures, which is essentially the heart of big data, enabled us to build big data analytics. And if you look at the current state, 2020, we are now mostly in AI and ML, where we um, mostly focus on how do we train the data to tell us what the trends are. Not that the gone are the days. I would not make that highly opinionated and judgmental statement or fatalistic statement. Uh, no, Excel has relevance, but it's got a minimalistic relevance. What we now look at data is, let's take your own ICFIA's core areas, um, costing and finance and fintech world, where you guys go out and support the financial industry. Um, Risk modeling. Is it worth to give a loan applicant the loan? How can we know the result by looking at the data, not talking to the person? What does it do? Then you to run parse your data and then build a model that tell, hey, no, this candidate or applicant A is more credit worthy than applicant B. So let's give this, or applicant A is less risk averse and than applicant B. So that's supervised learning, narrow AI. Then you say, I want this algorithm to look at my petabyte scale data, which is landed on big data platforms, and tell me um, a driverless car is a good example, right? If there are 1001 million variables, the different permutations, combinations of these variables crunched to identify a risk of a collision to ensure that a vehicle can be operated on any terrain. That's a wide data. You're kind of making, you're not going to train the data or algorithm on any data, but you're going to train in a way, but you're going to give a wider, broader problem to solve. So the point is from the 70s or early 60s to date, we have from 2000 to 2020, it's just 20 years. What we have done in 20 years is virtually what the IT or the knowledge worker industry has progressed from almost early 1900s, 1930s to date. And now let's look at a little more detail on this history. The history, big data is in isolation would not really work unless you move the on-premise data centers, which are to the leftmost corner, to the cloud and make them serverless. Somebody is having a server, but it's not the business. Why should the business which sells shoes or fruits or grapes or textiles or design way or furniture ever bother to stand up should waste money setting up a data center? So we take the on-premise, short for on-premise in US as on-prem. Well, I guess it's all over the world now. We take the data centers and then we give it as infrastructure as a service. This word, as a service, platform as a service, software as a service, data as a service, machine learning, the model as a service is where the industry is fast forwarding to. So throw it out in the cloud. How can let people come in and pay as a subscriber model, like you subscribe to a magazine and read, and you only pay when you read an article or 5 articles a month or 10 articles a month. So I want to only pay when I use 10 petabytes of data and 5 core CPU processing time as compute cycles. That's how the model has changed in the world. So why to really get a complete holistic understanding of data analytics, you need to understand big data. You need to understand cloud. You need to then understand the machine learning algorithms. Now this is a very critical slide. I certainly would draw your attention. It's too dense for sure. There are many names and faces and years. I'll draw your attention to Alan Turing, 1950. We owe it to him. The man died very young due to unfortunate practices in UK. He single-handedly is instrumental to shorten the world war by a good 10 years and probably save millions of people. If you watch the movie Imitation Game or read about him, you should. Every person in the industry should read about him. He kind of invented, it's still, even to date, it's called the Turing test in order to really test an algorithm. So you got to know his contributions. Enigma, the decoding machine that decoded all the Nazi Germany warship signals that were causing havoc in the English Channel and the sea of the coast of UK. sinking all the ships. Here, Mr. Alan Turing and his team decoded the signals by just using computers. His contribution is astounding. And then we now have 2016 to 2018, not far from 2020, right? 2014 as well, when Google bought a company in England called DeepMind, which then um, uh, there's a there's a game in China played. I guess it's more like a cult, a religious following called Go. It's much more than chess that was invented in India. So the Chinese take it as a next to their religion, and they follow it. And this is this guy, this AlphaGo beat their leader Lee Sedol, and then of course Watson also beat, but then Watson's approach was entirely different. Google's AlphaGo is an astounding advancement in AI. So this is a brief history of how AI, big data analytics has transgressed from the early 1600s of Charles Babbage's machine. And can never forget the contribution of Lady Ada Lovelace, Lord Byron's daughter. She virtually has to be considered as the first programmer in the world. We owe it to her for the constructs of if then else and programming. She and Charles Babbage were contemporaries. And the story goes that Ada's mother, did not want her to dabble in poetry or romantic poetry. So she made her learn math, and she became pretty good in math and started contributing, working or critiquing Charles Babbage's work and on his recommendations, and rewrote some instructions which were like, if this happens, then carry this out. So what we have now as if then else, one of the greatest languages named after her. So these are all great luminaries from obviously from about 2009 onwards. Most of the contributors from 1965 and 50, those are all still contributing to us. Now, this is critical slide. I would want everybody to pay attention. You got to know what the differences are between business intelligence, analytics, data science, and data engineering. The activities, excuse me, the activities we need to carry out in data analytics are from ingestion or integrating data sources to taking actions under the process column. So each role, the role are carried out by different community, different teams. So you need to understand this, that not all are to be can be carried out by one. But in data science, if you look at the last column, you end up doing virtually all. Well, it's not one person. Let me be very clear. None of these are one-person roles. They're multi-person team role. Now, let's look at how are we doing on time, Amit?
Yes, sir. Sir, you are on time, sir.
Okay, good.
Please go ahead,
Sir,
sir.
next 10 minutes, sir. You have only 10 minutes. After 10 minutes, Professor Malvi will start the question and session, sir.
Okay, sure.
Yes, sir.
Oh, sorry.
We are going great, sir.
Oh, wow.
We are going great.
Okay. So here's what we do. Like, let's understand what ML is, and this is again one definition which is critical. It's like to dumb it down. You're telling a computer instructing a computer to learn by giving it some data and an algorithm, which is your instruction to make it learn, and watch it learn. That word "watch it learn" is critical, though it's not there in this definition. The watch it learn in the next few slides will translate to training and testing. So let's say your company or the company that you're going to go consult and build some analytics solutions for has got 1 million records of data. And they'll say, hey, take this finance data, budget data, and go predict what my budgets would be for the next 5 years. Oh, by the way, this is historical data, which is 10 million more records. Tell me how accurate we were, or not we were, your model is compared to what the actuals were the last 10 years. So the learn part will be, you got to take 80% of the data, train the data on your algorithm on the forecasting, which could be Arima, Sarima, and FP Profit, one of those, using Python or R, I guess, and it could be R. R is a pretty strong language. And then you take it and then see the results, compare it, contrast it with what the historical results were. You don't do it in isolation. You have to do it with the team, the business stewards, business domain experts, or citizen data scientists, as the other term is in this field, goes, which is like the guys or the teams that are very close to the data. They understand the data. The moment they look at the data, say, oh yeah, you know why we had a dip in the third quarter last year? Because of this launching of a campaign. That kind of an association an IT guy would never be able to make. So you involve them, you test the data, so you train the data, and then you take, once they say they approve it, they be in the business, not IT, approve the model's results, then you test the remaining 20%. The testing is where you're virtually testing it on the production data. It's the same 1 million records, and then you go deploy it in production systems. So that's ML. You're training, when you're saying you're training the computer, you're not trying to build a physical living and breathing system. Mark my words, AI is not going to take over. Our fear of AI taking over or robots taking over will take us or take over us. And if fear takes over us, you can't, even the greatest scientists will not be able to achieve anything. So the fear factors, what we humans have to overcome as a perception bias. It's a toy, and you tame the toy, you control the toy. If the toy can go wild, berserk, or the robo that you're building will not listen if you program it that way. So this is a slide where you kind of differentiate between what ML is and what artificial intelligence is. I'm not going to dwell much time on this. And the speech part, NLP, is kind of becoming very critical now, especially in the COVID-imposed digital transformation that's really catalyzed the entire world to look at machine learning, augmented analytics, and so on. And now let's get to the meat of it. I guess this is of more interest to IT guys. I've been quickly looked at the chat questions. They kind of probably revolve around these, hopefully. So when you talk about machine learning, that supervised and unsupervised. Supervised means, yeah, typically classification. That is, the answer is binary, yes, no. So, which means a decision tree, which means, let's say, give an example. The example I talked about. You have, say, 1 million applicants for admission to ICFAI, theoretically. You classify them as made the cut, did not make the cut. So binary, right? That's a classification example. Regression is you want to know to the nearest millionth revenue stream look at the data and build a regression model. Give me all the nearest cluster points of all the trends that give me $1 million per quarter as revenue. So you're looking at numbers. You're not looking at yes, no. Then when you're looking at clustering and association rules and dimensionality reduction, that's a more algorithm driven. We can talk about it later. Maybe it's a webinar on its own. I'm more than keen to devote an entire lecture on machine learning. So unsupervised is you're not really, you're letting the algorithm train itself. Yeah, this is important. The algorithm learns the more data you throw at it. The algorithm learns better. So you're not supervising the learning. And that's how it'll form what are the nearest clusters to a given problem statement. I want to identify the nearest cluster of COVID breaks outside of Wuhan. That's one cluster example. Reduce the dimensionality so that my accuracy increases. There are a bunch of algorithms which do that. Now, this is critical again for deep data analytics, machine learning. How do you go about, right? What are the steps you carry out? So you prepare the data, you build a model. See, you're preparing and building a model right away. Then you're training the model on the data. Then tune. Tune is not an AM, FM radio tuning, or I apologize for dumbing it down. Tuning has got to specific relevance. It's like hyperparameter tuning, parameterization, as it's called in machine learning. And it's a science of its own. It's statistical significance too. And then you deploy and deploy the model on your machine learning, on your OLTP systems, revenue generating systems. And then validate your predictions. That's how you deploy and model. So these are examples of supervised learning, classification, regression, then unsupervised. I mean, this guys can take a look at it. We can go to the Q&A sessions, examples of what ML applications are, credit decisions, face recognition, but this has now become a controversial topic in most of the companies. This is as of last month, state of the press, as it's called, as it's referenced. The face recognition algorithms do a 98.9 accuracy on Caucasian faces, male, female. But when it comes to colored face recognition, it's pretty poor accuracy. So they're for misuse of misuse of such algorithms. They've prohibited those algorithms, Google, Facebook, and Amazon, and so on, Microsoft. So these are examples of ML applications and more relevant to you guys' areas of working, detecting fraud, detecting anti-money laundering, AML, Jarrow-Winkler algorithms. All these are fundamentally driven now more by AI systems. There is a impact. Your title had the word impact, Amit and everybody. The impact is going to be, you better be cognizant of this. AI ML would impact our jobs. Those jobs are not just driverless cars or Uber or truck drivers. Those are going to be banking, finance. Why would any company invest millions of dollars to find the credit risk or worthiness when an algorithm does it much more accurately and with minimal upkeep? So we're not talking about 50 or 100 years from now. We're talking about the next 10 to 20 years. when you guys jump into your workforce and really get into deep dive into your careers. So you be very cognizant of what AI can do, and you better master it. Now, yeah, this is what we in OTSI, we have built this IP or intellectual property to automate learning the data, exploring the data. And AI is three-legged monster, if I may. EDA, which is exploratory data analysis or exploring your data. Then the second leg is preparing, data preparation. And the third is machine learning. So you kind of, from the business understanding phase to model deployment, you should be able to carry out univariate, bivariate statistical analysis using R or Python, and go from step one, which is business understanding, to model deploy. And now the maturity, the learning organizations, as that slide was talking about, you have to basically mature to digital transformations. And before that, insights monetization, right? Insights monetization is key, which is like if your data analytics is going to not really serve any purpose unless we make data, as it's called, data as a new oil. You got to mine your oil and make money by selling it, the crude. The crude is data, insights are oil, refined oil. Excuse me. So if you look at Uber's valuation is much more than all the oil companies put together. And they don't have any assets other than information of a driver and a passenger and a vehicle. So they are able to draw conclusions intelligently to monetize that. That's the insights monetization. That's where the maturity model is. This is another slide which basically emphasizes how can you become data driven in your competencies. You got to distribute it. You got to have a distributed practice of all your assets. You look at your asset as information as an asset, and then pivot to orchestrate this asset across the entire organization as through a data-driven strategy, use case curation. So these are the words that we all have to become very familiar with and live and breathe. This is what corporate America is all about, and I'm sure India is too. Now, we work with AWS. OTSI and AWS are building a massive Niti Aayog project as we speak for the government of India, where it's like a Googleification of the central government's department, so they can go search for any central government, not just for government employees. I believe the goal is to let loose it to the people of India population. So we are using this SageMaker solution to stand up the AI ML solution. And we are upskilling our teams. So my point is not to sell AWS, but the point is to make sure everybody here understands that you need to look at it a three-legged monster. The frameworks at the bottom, the middle layer ML services are crucial. And you look at it from what the intent is and what the analytics is. And that's where the AI services are. And now I guess we're done. Now this is critical. I really want to emphasize this. Carpe diem is you got to seize the moments. You're all so young and driven, and you're in the best of the times ever. From an AI, ML, advent and tangential takeoff, exponential takeoff standpoint, you have to jump into the pool of learning AI, ML, and data analytics. You've got the best staff there. I'm certainly going to be keenly involved in your curriculum, shaping it, guiding your very intelligent and hungry staff, and certainly students. But never let this opportunity slip by. It is not. It's going to revolutionize and change our entire way of thinking, living, buying, selling, transacting. Period. I mean, COVID or no COVID, AI is going to um, be the way to go about. You gone would be, let's have a 100-member team to do our analysis. They would all be SaaSified. That is software as a service in the cloud, AI models. You pay for an AI model to do text recognition or image recognition or translation or forecasting my budget or detecting fraud, monetizing a bed. Imagine all these to be tapped into a cloud as a service and pay for it. So why would companies invest if I'm a hospital, Apollo or those kind of hospitals? My main goal is to monetize a bed. Unit of measure for me, for my revenue stream is a bed. Patient comes in an ER. There are multiple ecosystems that surround the patient, from a resource utilization, a specialist physician model, a general physician model, a nurse, the instruments that go around capturing the vital statistics of a human being. All these can be SaaSified. So it's seize the moment,
So we
never.
have some time constraints, sir.
Yes,
Kindly.
now we are good. I'm done. So, and these are references. I'm now up for all questions.
Now, Dr. Malviya will moderate the question. Dr. Malviya, please. Lots of questions there. Dr. Malviya, please.
Thank you, sir. Thank you. Mr. Raghu, it is Sanjeev Malviya from Assistant Professor, ICFI Business School, Dehradun. Sir,
Yes,
it was a privilege and a pleasure hearing you. Pretty engrossing session. A lot of queries and questions. You have stirred the young minds of our students.
great. That's exactly what I want to happen. It doesn't matter
Great,
whether
sir.
it's 1 a.m. you're in Kansas. So it's
Yes.
the
We are
the the
thankful to
the
you for
spark
that,
is
sir.
important. Yes.
Right. So I'll just club the questions. In fact, there are a number of them. One set of question is on data security and the privacy of the customers. The MBA students from the second year, Mani Shankar, Arpan Ghosh, and Ajay, they have concerns related to breach of consumers' privacy and data security. In fact, the question is, I'll just phrase one of the questions from these three. They are on these issues only. With
True.
increase of AI, there is more concern arising regarding the security of data and information which gets hacked frequently. What can be these possible steps to stop and prevent it?
Well, that's a great question. Honestly, it's actually what's stopping a complete adoption by, say, the financial institutions in the world, JP Morgan's or ICI banks or name any bank,
Yes.
from totally relying on AI models. There's obviously the but coming right from the IT guy that I am. What we do, and this is more to address the students who have raised this question, is data anonymization is a new science on its own. So how do you anonymize the data? Critical data, PII, private information of any customer, right? Name, social security, address. You kind of, hitherto what we used to do is, okay, let's actually put some numbers, randomize and create a random number, not visibly show the details or ever give an option. Then we kind of move to hashing the hash keys. We hash key the private information. Now, then if you look at blockchains, what's happened in the blockchain is CRUD versus worm. CRUD is like the typical create, read, update, delete. So all the problems in data breaches were because all the database systems were CRUD centered. You have multiple points at which you can go manage and change the data. The moment you give that ability, not you as in we, but the architecture facilitates that ability. It's limited architecture. So the ability to write multiple times on the same data will open up the doors to breach the data. Now, what's happened in blockchains is we kind of, the smart contracts as it's called, is a worm concept. That is write once, read many. So, Professor, if you create a blockchain key of transaction data, you hold the keys. You're not distributing the keys to the general public, where this data is going to go from, I guess, travel. So the recipient of the hash, the data set, which should be, say, another bank. In this case, assume it has to be a bank-to-bank transfer. Nobody in between should hash or should hack it and take the private information away. Then, after the bank receives the data set without the hash key, there is another algorithm which is only given through a hash key to the other entity to decode the hash key, or only then they can read. So that's still not the most sophisticated technology, but data anonymization as an algorithm by Google and by Amazon and driven by banking industry is taking the forefront to impose this data privacy. But thieves have given rise to lock industry. The more sophisticated algorithms become, the more sophisticated hackers are. There's a very thin line separating a hacker from a genius. Well, knowledge is nobody's personal property, so I can be in my pajamas in the basement and be a genius or be a hacker and break into a bank. So 90% of the problems are solved by data anonymization techniques. And Privitar, I think it's called, the tool that Google has, that they have built up these algorithms. I hope that answers your question. There's no one answer will say, yes, students, this is what it is.
Yes,
So
So
we
from
are
my end,
evolving
one
there.
question, if Malvish allow me, then I asked a
Yes.
question to sir.
Well, I
Sir, it is not.
Yes, sir. Please go ahead.
So it is not possible, Raghu sir, ki within a near future, the hackers may use the more intelligent AI-based codes to decode the securities of server and all the things, sir.
It's very likely because, in fact, what the CIA does is, if they go after the best hackers, and they say, okay, you guys, best hackers are pretty good programmers, and wait a minute, there is ethical hacking. Okay, in academia, we should building that module. There's called as ethical hacking credit hour. So ethical hacking is ensuring that a wider community of IT students practice hacking ethically. The same methods that an unethical hacker, if I may, indulges in. So the more you know the bad side, as the perpetrators of these algorithms who misuse it, the way they misuse it and why they misuse it. The why part is known. They want to obviously steal money or steal private information and sell it, or shame people like Snowden did throughout all the security information. So ethical hacking courses. And to your question, yes, it's possible. But ethical hacking has really taken shape as a credit hour in most of academia to work as a counterbalance to the hackers. And it's like a day job. It's like it always happens. Hacking, well, you cannot eliminate it. You cannot fight it. You can only live and know and master and control it. So the way you go about doing it is like what happened to Bangladesh Bank, right? I guess between New York Bank and Bangladesh Bank, millions of dollars were lost. Not millions, one or two. I guess hundreds of millions of dollars because of this fraud. So it's possible, but the ethical hacking and stopping the hackers from ever indulging in theft and increasing the premium, increasing the bar to criminal justice reforms where not criminal, just blue collar and white collar crimes of hacking into financial institution private information has changed. It's not treated as a close to second degree. So you increase the deterrent. If you're caught hacking, you're thrown into prison forever, no parole. Imagine a brilliant guy doing that. Would if I know that, yeah, I can hack into this bank, but hey, if I get caught, what's the point of me having 100 million? I'll be just, orange overalls counting bars. So no, their society is really rapidly catching up. So law enforcement agencies.
That is good, sir. I hope, in fact,
Sanjay Malia.
Yes, sir, Professor. Sir.
See, Mr. Raghu and Amit, I want to share an experience with my previous organization. Yes. In my previous organization, we had a Bachelor of Computer Application and Master of Computer Application. Now, what we did for this, both the courses, as Raghu told very clearly, academic year, we have to introduce something there. We have introduced an ethical club. So we made a team of 10 students, and we have given them 10 months time to develop an ethical software and show us the life. Believe it or not, one day 2 students came to me and sat in front of me, and they were talking to me. Then after 5 minutes, the student told me, "Sir, aapka phone main hack kar diya." Then, believe it or not, it's a live example. I'm telling to you, the phone was my BlackBerry. My total information on my phone has been hacked by his phone directly.
Wow.
He has shown me everything on his phone completely.
Yeah.
I'm talking, this is exactly 3 years back. 3 years back. The same guy also had made one syndrome also, that one camera one and all the things.
Oh, yeah.
And as Raghu said correctly that. So in the academia also, we should make the students aware and make them to implement the practicality. And it has been proved. And the students of BCA and MCA have developed an ethical software and hacked my phone numbers and everything. Yes, please.
So that's a very good point. Let me add to Professor Vinay's very astute observation. What academia are thinking about and probably going to launch is hackathons. Let's say ethical hacking hackathon. You normally conduct an exam, right? So we have a term exam that we cannot avoid. Let's say one of the internal assessment test is a hackathon, and we give everybody same problem. There are different ways to tackle that problem in programming, and you define what the end goal should be. So let there be hackathon competition of teams, because programming is never done in isolation. It has to be done as a team effort. Let's form, suppose a class of 30 students, form it not more than 5 in each team, 6 teams, and let them participate in the hackathon and write the programs and solve it. So that way you kind of become, you drive your gray matter, you solve the problems, you learn the skill, you put the skill to use to build a product, all in say 2 hours. This is exactly what happened in a hackathon that when I led my team in 2013, the Kansas City Police Department came and gave us a data presentation saying there were 15 teams and from all over the city. And we were given the different kinds of crime data, crime by zip code, crime by by street lights broken, city water main broken, and by alcohol licenses street. So we took all the data, integrated the data, and then found a pattern saying there is more crime during this time from this specific zip code. And we also found that a police vehicle just going through that city, that street during that time, during another time has there was no violence, there was no crime, only because there was a police vehicle going through that street at the same time. So we recommended these simple measures and the crime fell down. So the point is hackathons are the right way to go about in academia. I hope this answers your question.
Yes, sir. It certainly. Thanks, Professor Dr. Muduvine, for that an interesting example, sir. There is another set of questions, sir, which we would like to address. And before we go to that, I'd like to say to my students, most of the students were concerned about this data breaches and security. So we have, in fact, as suggested by Mr. Raghu, data anonymization and blockchains, they come to the rescue. Now coming to another set of questions, which is being raised by a few of the students, they're name the students also. These are India build a good foundation into artificial intelligence, robotics, machine learning, cloud computing. How can India emerge as a strong contender into these domains? So,
well, India is there. I was just joking with Amit earlier. Silicon Valley, IC is joked as India and Chinese, not integrated circuit. But California, that is. If you look at Silicon Valley per se, Stanford University, UC Berkeley, that belt. If you take Silicon Valley, which is truly not a mountain valley like Dehradun or it's just a hypothetical map, the Silicon Valley per se is maybe ranks 15th or 20th in the world GDP. And the entrepreneurs, the VCs, and the knowledge workers contributing to that growth through product launches are certainly mostly not, well, significantly from the Indian diaspora. So we are there, but we have to be very organic, which is we have a service mentality, whatever be the historical reasons. The service side of the factor has enabled us to launch our IT industry. And for the first time, if you look at Indian GDP, last 10 years in a row or 20 years in a row, IT services per se have contributed to the GDP. To the student's question, India has got a very strong backbone for the following reasons. The middle class population of India is almost 460 million. And the age group that contributes to the growth of a GDP in any world, any country's GDP, is typically the 20 to the 60, 65. Okay, 70. Let's take 20 to 70. Now, the replenishment model of how healthy the workforce is being replenished as people retire, and into this age bracket, the cohort analysis, that's one word. You take a cluster analysis, you can do this. If you do that analysis, India is the only nation in the world where that model is the most healthiest by a degree of 10 points to the next nation. Let's take a most immediate competition, China. China, by the way, is way ahead of us in AI. They spend $200 billion a year on learning, mastering, spreading AI. The world totally disagrees with the way Chinese do it. That's a different topic to discuss. But the point for us is China, being our immediate competition, has got an inherent problem. Their aged population that requires care is close to 480 or 450 million. So let's assume their GDP is 10%. They take a good 1% GDP goes into taking care of the aging population. That brings it to 9. They have this artificial way of incubating employment. So Shanghai, Beijing, 10,000 kilometers, they build a bridge. After 10 years, they demolish it, even if one person doesn't walk on it. Again, employ the same 10,000 or 20,000 folks to build it. So that takes a 1% GDP away. So you have 8% left. Now, how does China grow their GDP or industry? Is through a non-organic way of incubating industry. Let the acquired company run its course for 5 years, completely bring it Chinese way, and then completely clone the products. Good, bad, ugly, imitation, loss of IP theft, that's a different topic. But the point is, India is a democratic nation. Indian middle class is growing, young, entrepreneur. And the VC, this is important. The VC industry, venture finance, venture capital industry in India is growing organically. And if you look at the investments, unfortunately, not unfortunately, others do still have controlling stakes like Alibaba and Tencent and all these companies. Even in companies like Big Bazaar, they're not entirely owned by India. They're partly owned by Chinese. So the point is AI has got great future. We are making a lot of strides. In fact, I talked to quite a few 5-member team, 3-member team on, so could you give us invest in our company? We have small company in Hyderabad or wherever. We are building this speech analytics. We have this software. We have this. So AI has become a cottage industry, and it should logically because it's a knowledge worker industry. And India is really good because we really focus a lot on engineering. You call the IITs. IITs could be only 10 or 15, then NITs, another 50 in the country. Then you have the private engineering institutes, could be like ICFAI too in the technology space, another 500. So if you add up all these, you have 1,000 such institutions. And throwing the MCAs, we are not even counting the MCAs. You take this 1,000, take a very conservative measure, only 20% are quality, which is, we know it's more than 20%. Let's just take a 20%, 1,000 times, if you take 50 students and 20%, that's a significant contribution to the knowledge worker pool in India. And no thanks to COVID, there's less brain drain now. And mark my words, if this were 30 years back, I would have never come to US. If this is what AI was when Vinay and I were students, I would still be there. I mean, IT is, you don't need to be anywhere. You need a laptop, a cloud account, and that's it. So to the students' points is very good. I would say be very hungry. Be very hungry. Hit your keyboard. There's nothing more critical than hitting the keyboard in AI. Learn those models. I forgot to include this in the reference. I will. Fast.ai. Can you give me a minute? I want to get a glass of water and bring a book I want to show the title.
Sure, sir. Sure, sir.
Malvi sir, today's discussion is very healthy.
Yes, sir. In fact, the students are also very interested and they are
Yes.
inquiring, and lot of queries we are seeing.
So today I have learned lots of things because this is my area of interest, AI.
That is pretty interesting area also, sir. We all, in fact, have our limitations in this area.
Yes, sir. And besides this, I am also noting that students they have launched very good questions, very
Yes, sir.
deep questions, sir.
Lot of them, in fact, are inquisitive to know about lot many things, both
Right.
your engineering and the MBA students. So
Yes,
it's
sir.
good, in fact.
The level of question is very nice, sir.
And that is why I said it has stirred the thought process of most of our students.
Yes, sir.
And
Okay,
then we
then.
are,
Close?
Please, sir.
yes, sir.
No, sir. No, sir. Sir is coming.
Welcome back, Mr. Raghu.
Sorry about that.
Okay.
Yeah,
This
welcome
is a
back, sir.
this is a very important book that we all
Sir, it is
have
not
to.
visible. Sir, book is not kindly, sir. Yeah. What is the name,
Yes,
sir?
yes.
It is AI superpowers,
Okay.
and we should know Vinay. OMC, Omega Microcomputers, Dr. Raj Reddy.
Yeah.
He is considered to be the father of AI because he
Okay.
is at CMU, Carnegie Mellon University's lab.
Okay.
And this author, Kai-Fu Lee, is a student. So he compares China and Silicon Valley. Both have actually how they have kind of looked at AI. And it's a very interesting book, and everybody needs to read it, especially leaders in India. So the way Chinese go after it is different. They want to control, and I don't think India wants to control the world. AI is just make money or solve problems. Anyway, the point is AI, the student who asked that question or set of students, it's a very good question. We are at the cusp and we have an advantage. We have to never let go of the advantage. We in India have a much stronger backbone in technology, education, emphasis on education, and the quality gap of excellent education, great education is fast reducing. There would be poor quality institutions all over the world. I mean, believe me, there are towns here. It's no different here than any part of the world. So we have to exploit that, and we have to really dig deep and then work hard. I mean, almost all students work hard with a purpose, being learning AI and learning machine learning, mastering data analytics. Have your focus on result. Why do you want to learn it? Everybody, because I attended this lecture by Raghu and he's from US and he's talking, no, that won't cut. It should be from within, organically. I want to do it. Read that fast.ai. That's fascinating because it opened up the eye that AI is not for just techies, geeks, math guys. It's for anybody.
Great, sir.
Yeah, I'm open to any kind of, I'm not limited by half an hour or anything. So I'm more than open to,
And
I have no place to go.
Raghu,
Yeah.
regarding this AI and machine learning, I wanted to tell you that ICFI University Dehradun is planning to set up by Center of AI.
Oh, nice.
I think we are planning to have a eminent personality, and this is initiated by our Amit Das, who is
nice.
heading this Center of Artificial Intelligence and all the things.
But
And
the
we have
brainchild is
already,
yours, sir.
yeah, we have already procured the latest missionaries and all the things. I think by next within 2 weeks, we will be setting up a center of AI and machine learning in ICFI Dehradun. I think
Very good.
with your inputs, I think we will also invite you for
Oh,
one of the
wow.
advisor to take forward the Center of Artificial Intelligence under the leadership of Mr. Amit Das.
Oh, well, excellent. Wow. Congratulations. And yes, Godspeed and good luck and
Raghu
best
said
wishes.
Raghu said this brainchild is by our honorable vice chancellor, sir. Basically, it is designed by sir.
Of course, yeah. Mr. Vinay, I know him. He's my brother. He's like my brother, so I know him very well.
I think
He's
we can conclude.
Now, if the students have any more questions, I can.
Sir,
I'm more than free to answer. That's okay.
I'll just add one more thing, Mr. Raghu. Since Professor Dr. Mudubina is sharing some wonderful not only experiences, is in fact the future plans which we have. I'd just like to put on record, and we all know who are a part of the ICFI, just to share it with you, sir. ICFI University Dehradun has been ranked in the world rankings as the ranked 44th amongst the innovative universities in the world's university with the real impact ranking for 2020. It's a significant achievement.
Wow.
We being the
fantastic. Congratulations.
Thank you, sir. Thank you, sir. Thanks. In fact, it is a wonderful achievement, pioneered, headed, and led by Professor Dr. Mudhu Vinay. It is, again, I'll just summarize what sir has said. It is heartening again to know that India is on the cusp and have an advantage in terms of AI machine learning. For my students, sir, I'll just take one more question.
Actually, I have 3 questions here that I want to answer. Okay. One is on the quality and lack of skilled resources in machine learning. This is by Anudeep.
Anudeep, sir.
Anudeep. And there's one more from Mandar. Can we use AI and data analytics for social and humanitarian purposes? Yes. I'll add these 2 to the question that you have. You first, please go ahead and ask your question.
So you can go ahead with these 2 questions. I'll put that this question towards the end. This will be the last question which I'll be.
Well, the answer on data quality and ML is yes. Poor data quality can easily be solved by, if you look at the slide presentation I made, data profiling. Well, capture the missing values, missing nulls, wrong values in different columns of data. And then you can go cleanse it and say, statistically impute. Let's say you're looking at a column full of ages. Okay, you have 5 values which are not having any, 5 records which do not have any values for ages. So statistically speaking, what you do is you impute it. So you take the average of all those 30 age values. You'll not be wrong if you plug in the missing values by the average. Okay, if it is of student community, they'll all be say between 20 and 24, depending on which module program they are in. If they're say school going, then they'll be say 15 to 18 or something like that. So if some records are missing, you're not really inflating the values or bringing in any bias, statistical bias, by plugging in a statistical average. That's the way to look at it from cleansing the data.
Right.
And social causes, yes, there are plenty of social causes and humanitarian purposes. How do you look at impure water treatment plants for impoverished societies using AI? How do you analyze the spread of a disease, example, COVID, in minority communities? How is the behavior of a patient from a different financial status, their treatment or ability to respond or have access to treatment can be modeled using AI. Literacy rates, and then fraud. All these are social humanitarian causes too, crime. And before an adverse event happens, you can even capture a criminal act. So yes, the answer is yes. You can go ahead and ask your question, sir.
So, in fact, most of the students have shown concerns and are interested to knowing from you, sir. Any few tips, maybe 3 tips, if you can give to them in terms of preparing themselves for the career post-pandemic or post-COVID, or in next, in fact, down the 6 months down the line, even if COVID is there, even if the coronavirus stays, how do these students prepare themselves for the coming future? Any few tips, 1, 2, 3, whichever comes to your mind, sir.
Yeah. So this is based on the assumption of the student profile. There could be multiple cohorts, your brackets or buckets. Some are in the purely non-IT, non-technology areas. They would mostly be on the business areas, business analyst. For those groups, I would say,
Yes, sir.
You guys and girls would have to focus on bringing in an analytics flavor to your business understanding of a given industry that you want to go and get into. Not to code, not to use Python or R to solve problems, but interpreting. You are the citizen data scientist, which means you'll be knowing the industry domain very well, should be knowing as you progress in your career. But you have to be able to interpret data and drive decisions through the data. So that's for the folks who are not in IT. But the folks who are basically in IT, the students who are going to be in IT, it's very critical to get into the grooves of rolling up your sleeves, learning what data ingestion is, learning what cloud technologies are, learning what model building is, exploring the data is, in that order, exploring the data, preparing the data, building the models, training and testing the models, deploying the models, and fine-tuning the models. And I'm using these terms not on a high level, but these are very relevant, specific terms. And the folks who are very keen on becoming gurus and experts in security and ethical hacking and cybersecurity, that's a massive industry on its own. So with Dr. Das and with ICFA and Dr. Professor Vinay driving this initiative to stand up AI lab and instead division, that's where you guys should spend a lot of your time and live and breathe coding, Python and R, live and breathe hackathons, complete your MOOCs, get into MOOCs that is massively offered online courses, the Coursera, the Udacity, the Udemy. It's not just that you one and done. That is, you come to ICFAI and learn and go. No, you have to be a lifelong student. Read books relevant to this field, like the one I showed. Important for coders because I'm more of a coder. Get into Kaggle. Kaggle is Kaggle. It's like a worldwide competition. And companies throw out business challenges and people provide their solutions. So there are, as you become an expert in Kaggle, you're ranked, you get stars and you become a grandmaster. You start solving more problems. And the moment you get a higher rank, that's Kaggle is, by the way, a Google company. So they let it be independent. So those guys they make $100,000 a year, the grandmasters, by just sitting in the house and solving problems. So get into such competitions, get into online hackathons, get into boot camps. Never stop learning. Any institution in the world, IITs or ICFAIs, can open the doors and make you curious, make you hungry. And you should constantly have the passion and initiative and drive to learn on your own. You could use HR for human. If people are interested in going into HR side of MBA, then human analytics, like which, based on the industry that you're going, the HR division is, say banking or drug manufacture or IPL, sports industry. You have to understand the industry, learn the data science behind it, hire the right people. HR guys get involved in hiring, talent acquisition. Learn the analytics side of what an ATS, automatic talent search, or whatever it's called, tracking. Algorithms do to get you the best hit ratio on the keywords in a resume. So HR folks have to learn this part too. There's no way that they can just, sorry to use the phrase, paper pushers, trying to only confine themselves to paperwork. Anybody for that matter. So no matter which, as you must have now noticed, no matter which department or which line of business or career path you want to take, it has to be data centered, which is exactly what COVID has told us. It's going to be remote, cloud, data savvy. Jobs will most likely be a lot more in India because I see the trend happening in US. Hey, we are now learning to see we can still be productive with people not coming into the office. Our customers are saying. So, but don't be complacent. Don't think that, we'll get jobs, so we are okay. No, we will be okay. In a nanosecond, that will disappear. Because corporate America is nothing that even corporate India is different. Corporate America is absolutely transactional oriented. So you have to keep in mind so this is the paradigm that we are living in. We are in the right cusp. It's unfortunate we're losing lives and worldwide. It's unfortunate that be cognizant that science will cure this. We'll have a vaccine, but we also be very cognizant that we cannot expose ourselves to a herd immunization philosophy saying the more you go get exposed, the antibodies are created. No, it is not that type of flu. So be also aware that the younger folks are also falling sick. The age 35 and below in US has really spiraled up cases. So COVID has opened up the doors, be focused on data centered. If you're going to be, IT is not my cup of tea, be very strong in your domain, but be cognizant that you will be asked to analyze the data. I hope that makes sense.
Right.
Certainly, sir. I think that the most majority of the queries have been excellently covered, sir. We'll be winding up the session. Before we do so, I'd like to sincerely thank you, Mr. Raghu, for an enlightening and engrossing session on importance
thank you.
of applying data analytics and decision making, sir.
Thank you, sir. Thank you very much.
Thank you, sir, for this having this perplexing area demystified. Data and analytics are certainly disrupting existing businesses, sir. And your advice to focus on using analytics for driving strategic business decisions is very apt. Rather than going with the gut, if managers are data driven, it will certainly help to keep their corporations ahead of competition. Your views on democratizing AI are indeed stimulating, and it can be seen from the queries and the questions it has stirred amongst the participants. We thank you, sir, for a truly memorable web talk, sir.
And thank you very much. It's my honor. Thank you.
Sir, it's a pleasure, and we sincerely hope that you can join us again in near future.
I will.
Also thank, sure, it will be our pleasure, sir. And I thank our Vice Chancellor, Professor Dr. Muthu Vinay, for conceiving this ICFI Web Talk event. Sir, your initiatives have always helped to enrich the lives of our young students, whether it's engineering, it's management, or education, or law. Thank you, sir. I thank our Registrar, Brigadier Rajiv Sethi, for his constant support and encouragement. My appreciation and thanks to the program convener, Professor Amit Das, event coordinator, Dr. Sanjeev Kumar, our technical coordinator, Mr. Akhilesh Singh, for the contribution in organizing this event. My sincere thanks also go to all my faculty and staff colleagues, my students, and all the participants. It would have been, in fact, it not have been possible if our participants and the students would not have interacted so well. We again look forward to seeing all of you on 30th June to another interesting session with the business chief of Panasonic India. Till then, stay happy and stay healthy. Thank you once again. Thank you, sir.
Thank you very much. Good luck, everybody, all the students and the staff. Thank you, sir.
Thank you, sir.
Thank you.